Hello. So this is going to be the second video in my incredible Sudoku series, where I focus on classic Sudokus and some advanced technique and theory in relation to those. And so my plan here for this and moving to the future is to have sort of a theme of particular technique styles and also go a little bit more into the theory of how those work and some new terminology so we can sort of build on that. And we'll see how this goes. So this will be kind of like the Learn Sudoku series, except for people who really like Sudoku and really like the advanced classic techniques. So I hope that's you, and I hope you enjoy this. And we'll see how this goes. So the plan here is to do 2 Sudokus in this video, and the focus will be on one specific technique that's similar between the two and much more similar than one might initially expect them to be once you start introducing some of this interesting theory and terminology. So I think what I'll do is I'll start by doing the basics on this Sudoku. Then I'll show the traditional way of kind of looking at the technique that's unlocked. And then I will show the way to think about it in sort of more generic technique terms. We'll finish off that puzzle, and then we'll do a second puzzle, and I'll show why I went into that technique and how that helps with the second puzzle. So hopefully I can jam that into a short enough video. We'll see how that goes, and I may edit things or speed things up depending on just trying to keep for time. These are showcases. I've done both puzzles before, and this is heavily prepped video. So in the links below, you will find 2 classic Sudokus. One's called Lapidaire, it's by Shye, and one's an unpublished classic by Newman. Feel free to give both puzzles a try. I think you should be able to complete both of them. You may not complete them exactly in the way that I do so in this video, but do give them a try first if you would like to, and then come back and finish this video. So I'm going to get started on this one. Like I said, I'm going to do the basics first to unlock the technique that we want to do. And then I'll do the technique and show how that finishes off the puzzle. So let's get started. So we obviously want to start with any hidden singles, as we always do with classics. So I know that these 2 7s look down here. This 7 looks over here. So we do get a 7 hidden single right there. Also, if you look at the top row, where can 6 go? Well, 6 can't go here. 6 can't go anywhere in this box, and this 6 looks up here, so there's a hidden 6 in row 1. And then if you look at this column, where does 1 go? Well, none of these can be 1, this can't be 1, and this can't be 1 because of these ones over here. So we have a hidden 1 here. And that's enough to show this technique. You might find some pointing, some things that are limited to a couple places, but what we're going to focus on are these 4 cells. So what are the candidates for these cells? Well, this can be 1 or 2. It can't be 3, 4, 5, 6, 7, 8, or 9. So it's only 1 or 2. This cell here, it can't be 1. It could be 2 or 3. It can't be 4, 5, 6. 7 is here, and then 8 or 9. Let's just do this one next. So we can be 1. We can't be 2 or 3. We can be 4. We can't be 5, 6, that's the wrong 7, this 7, 8, and 9. And then over here, you can probably guess what this one's going to be, just based on our pattern here, but you can't be 1 or 2. Can be 3, 4. Can't be 5. 6 is here. And then 7, 8, and 9. Okay, so this is heavily telegraphed by Shye just by having these be some of the few by-value cells. I know you're probably not immediately going to find them in your own solve, but obviously I knew where they would be, so I just picked them out. And you can see that they're all from 1, 2, 3, 4, and they would form a quad if they all saw each other, but they don't all see each other. So sort of the traditional way to look at this would be, pick any of the cells. Let's just pick, let's pick the 1, 2, since it's the 1, 2 to start with. What would happen if this were a 1? Well, if this were 1, this would be 4, 3, 2. And if you kind of think of this still as a 1, 2, that 2 would then come back and make it a 1. So in one direction. If it's a 1, it's a self-fulfilling prophecy of looping back around and making it a 1. The only other option is if it was a 2, in which case we can go the other direction. If this was a 2, this would be 3, 4, 1, and then the 1 again looks back up, making this again a 2. So again, it loops. So that means because it loops, we can start at any of these cells, and that's a valid starting point for the loop, and it has the exact same effect. And you can try that yourself if you want. Like start here, see that it loops around this way or this way, depending on which value you choose. And what that means is that there are actually only 2 states to the world in terms of solving this puzzle, right? The first state is this being a 1, in which case we have 1, 4, 3, 2. And the only other case is if this was a 2, in which case we have 2, 3, 4, 1. Those are the only 2 options. And in each one, each cell was 1 or the other. And so what that means is, could I have a 1 in any of these cells? Like, let's say this was a 1, right? There's no reason to believe it couldn't be. But what would happen is this would become a 2, and this would become a 4. And those are the wrong states for our loop, right? This 2 makes this a 3, and this 4 makes this a 3. You have 2 3s in this column. So we know that one of these 2 is a 1, one of these 2 is a 2, one of these 2 is a 3, and one of these 2 is a 4. So none of these can be 4, none of these can be 3, none of these can be 2, and none of these can be 1. And that, with that, you can solve the rest of the puzzle fairly simply. Now, before I go do that, I want to point out a more theoretical sort of terminology way that we can describe this loop. And by the way, this is called an XY ring, in case you want to know the actual name of it. But let's talk about links. So I don't think I've ever touched on that in this channel before, but I want to introduce it as early as possible so we can start talking about these techniques. And I'm going to do a much longer video on links in the future, but I'm going to go very briefly over what it means to have a weak link or a strong link between 2 candidates. So we're always talking about 2 different candidates when we're talking about links. So that could be 2 candidates within the same cell, or a candidate in one cell and a candidate in another cell. So what is a weak link? What's a strong link? Well, a strong link, let's start with that. A strong link says that one of the 2 candidates is true, or both. But we can't have neither of them true. So a bi-value cell is actually the most basic form of that, and I can show a few different forms. But a bi-value cell, this is a 3 or a 4. So that, I said the keyword "or" there, and so that implies strong link. So this cell is either a 3 or it's a 4. Now in this case it can't be both, but we don't care either way. It can be both or not both. Either way, we have a strong link because we use that word "or." So it's a 3 or a 4. So there's a strong link between the 3 candidate in row 8, column 8, and the 4 candidate in row 8, column 8. That's a strong link. Another example of a strong link would be if you have, say, let's say you found an X-wing. So let's actually point one out in this puzzle. So 8s are limited to these 2 cells. And that's enough to go on, but let's talk about here as well. 8s are limited to these 2 cells over here. 8s are limited to these 2 cells here, and 8s are limited to these 2 cells here. So for, in this case, these 2 8s. So in this column, we would say 8's limited to these 2 cells. Another way to put that is the candidate 8 in this cell has a strong link to the candidate 8 in this cell. So 8 is either here or here. And now in this case, also it can't be both. But again, we don't really care about that. What we care about is there's a strong link between the 2 candidates 8 here. There's a strong link between these 8s. There's a strong link between these 8s. There's a strong link between these 8s. So what does that actually mean? And I guess another thing to point out would be, not only is there a strong link between these 8s, there's also a strong link between these 2 8s. And that's because we formed an X-wing. That what the X-wing has actually done is it's taken a strong link in say this row and a strong link in this row between 8s that line up in the columns, which then forms a strong link between the 8s in the columns. And once you have a strong link, what you can say is, well, because the 8 is in one place or another place, or both, and in all these examples I've given so far, it couldn't have been both. But what that means is any cell that is seen by both of those candidates cannot be that candidate. So in the case of the 8, we have a strong link between these two 8s, which means none of these cells can be an 8 because they are seen by both of these 8s, and there's a strong link between these 8s. Now, the 3 and the 4 is a little bit not as exciting because the 3 or 4 strong link, we can't do any eliminations with that because there are different candidate numbers. So, maybe if there was some kind of we could think about, say, non-consecutive. If there was a non-consecutive rule in this puzzle, which there's not, then we could look at this cell and say, well, the 3 and the 4 both see the candidate 4 in this cell if we had non-consecutive, because the 3 would eliminate the 4 in this cell and the 4 would eliminate the 4 in this cell. So there's a strong link between the 3 and the 4 in this cell. And because there's a strong link, any candidate seen by both of them, which in this case would be the 4 candidate in this cell, is eliminated. So we can think of it that way. I mean, obviously, you can think of it in a much, more general sense. It's a lot easier to comprehend, just sort of intuitively. But that's sort of a more strict terminology way of describing what has happened there. So for every strong link that you can form in the puzzle, you can do potentially eliminations based on that. And so now the strong link between these that were formed by the X-wing, the strong link between these that are formed by the X-wing, we have a strong link here and a strong link here, which means anything seen by these two can't be 8, anything seen by these two can't be 8, anything seen by these two can't be 8, and anything seen by these two can't be 8, and that leaves just one spot for 8, which is right here, right in the center of this box. So aside from the XY ring that we found, there's also that sort of 8s there. And I used that to sort of explain the strong link terminology. Another kind of neat strong link, and so just to give one example of how you could form a strong link that isn't an exclusive OR, would be, for example, the two-string kite, which I showed in the previous video. I actually showed 2 overlapping two-string kites. But if you have a single two-string kite, just to remind you, now this doesn't happen in this puzzle. There might be one in this puzzle, but I don't know. I don't specifically know of one. But let's say we have some value, let's say 1s. It's not in this case, but let's say 1s were limited to the 2 purple cells and 1s were limited to the 2 green cells within this column and within this row. Then we sort of have sort of a rotated X-wing, and this is called a two-string kite, where one obviously can't be in both of these cells. So that means that at least one of these 2 cells is a 1. And it could be both. We could have 1 in both of these cells because they don't see each other, but at least one of them is a 1. That forms a strong link between these 2 cells on the candidate 1, meaning that any cell seen by both of these cells wouldn't be able to be 1. In this case, that's this cell. So we could eliminate 1 from this cell, if that were the case. So that's one case where there's still a strong link, but it's not an either or. It's an or. One or the other is true, or both. And the or both is kind of that optional part of the strong link. Okay, so that's a strong link. What's a weak link then? Well, a weak link is not and, which, if you know any logic theory like discrete math, you'll understand the difference between or and not and. So not and, if you sort of use, I think it's L'Hopital's rule, you can sort of put the and into there. So in fact, let me just really quickly pull up a notepad here. So let's just write this out. A strong link, maybe I can make the font bigger. Okay, so strong link is A or B. A weak link is not A and B. Let's make this a little bit bigger. There we go. And if you remember your discrete mathematics, not A and B, that is the same as not A or not B. So you can, whichever way you want to think about it. I think a lot of times it's cleaner to think about it in this form. But if you think about it, what this means is you can't have both be true at the same time. So one of them is untrue, or both are untrue, but we can't have both be true. So that's why it's a weaker statement than a strong link. Strong link is saying one of them is true, at least. This one is saying at least one of them is not true. So you might be able to think of a few weak links here, but for example, within every column, you're going to have a weak link between every candidate between the cells, and in every box and in every row, because you can't repeat. So let's say if I were to mark everywhere a 1 could be in this column. So any of these can be a 1. This one can't be a 1, and this one can't be a 1, but this one can't be 1. So any of these 3 is a 1. And so there's a weak link between all of these 1 candidates. There's a weak link here, there's a weak link here, and there's weak link here, there's a weak link here. The 3 weak links have formed here. This one to this one, this one to this one, and this one to this one, there's a weak link. What that means is I can have one of them be a 1, but I can't have both of them be a 1. It just breaks Sudoku rules, right? So the board starts with just a ton of weak links already seeded because of the rules of classic Sudoku. And as we solve the puzzle, we're actually, you can think of that as removing or making irrelevant weak links until finally you have none left. You can also say that between for strong links, there is not necessarily a weak link, but you can have a link be both strong and weak. And that would be the XOR condition. So some people call that an XOR link. You could call it just as separately having a strong or weak link, but that's A XOR B, which means A is true or B is true, but not both. So if you combine the strong link and the weak link, let me just make this a little bit bigger, then what we're saying is A or B and not A and B. And if you think about it, that is the same as having an exclusive OR condition where one of them's true, but not both of them. So there you go. That's an XOR link. So this example here between these 8s, or even these 8s, this is an XOR link because there's both a strong link and a weak link between these. Because there's a strong link because at least one of them is true. We proved that by forming the X-wing. But there's also still there was since the beginning of the puzzle a weak link between these two cells already, and that's not destroyed by forming a strong link. You now have actually just made the super strong link of the XOR link. So there's nothing specifically special about the XOR link except that the link between these candidates can be used anywhere that you would need a weak link or a strong link. Whereas when we were talking about the 2-string kite, these two cells, there's a strong link, but there is no weak link between these cells. We have not proved a weak link. So it can be used anywhere you need a strong link, but it cannot be used anywhere you need a weak link. Okay, so I'm sorry for the huge tangent there, but now let's think about how we can use that. So another way to think about strong links and weak links is a strong link says, if not A, then B. So let me form a new, let me open a new notepad here. Let me make sure my font is still big. Okay. So strong link, right, is A or B. You could also say, if not A, that implies that B is true. So to put that in more human terms, let's think about the strong link between these 8s. If this 8 is not an 8, so if this is not an 8, where does 8 go in this column? Only here. And that's proven by the strong link, because A or B is true. One of these has to be true. So if this one's not true, then this one is true. So a strong link can be sort of seen as, if not A, then B. How about a weak link? Remember, weak link was not A and B. So what that means is if A, that implies not B. And so that's kind of what I would, that's the most basic rule of Sudoku, if you kind of think about it. If this is an 8, this is not an 8, because there's a weak link between them. They're in the same column. You can't have two 8s in the column. So if this is an 8, this is not an 8. So how do we use that? Well, there's something called AICs, alternating inference chains. And I promise this is going somewhere. So with alternating inference chains, you alternate between strong links and weak links. So let's talk about that. Well, and let's talk about that in terms of this XY ring. XY ring, sorry. So let's start here again, and let's say if not 1. So we have a strong link between the 1 and the 2. And we can say if not 1, then 2, because we have the strong link. Then we can say, well, okay, so let's this is actually convenient because let me open a third notepad here. And I'm going to use a slightly smaller font, I think. I hope you guys can still read it. But we have if not 1. So I'm just going to say it not 1 implies 2. And this is in row 2, column 2. So now what we can do is say, okay, well, let's use a bit of a better terminology here. So what this is going to mean is if 1 is not in row 2, column 2, that implies that 2 is in row 2, column 2. And that's because I have a strong link between the 1 and the 2. Now what we can say is if 2, then not 2 in row 2, column 8. So this forms another chain here because we're saying 2 is in row 2, column 2. Then that means that there's not a 2 in row 2, column 8. And that there implies there's not a 2 in row 2, column 8. Well, there's a strong link to the 3 in row 2, column 8. That implies that we have a 3 in row 2, column 8. We can keep going. That's going to imply that there's not a 3 in row 8, column 8, because we can see if there is a 3 in row 2, column 8, there is not a 3 in row 8, column 8. And then that implies that there is a 4 in row 8, column 8, because there's a strong link between the 3 and the 4. We're almost done with this chain. So that's going to mean that there is not a 4 in row 8, column 2, which implies that if you look, there's a strong link between the 4 and the 1 in that cell. That means there is a 1 in row 8, column 2. And a 1 in row 8, column 2 finally implies that there's not a 1 in row 2, column 2, which is our initial assumption. So in this case, we have found what's called an alternating inference chain. So another way to write that would be we can use an equal sign for a strong link and a minus sign for a weak link, because you kind of have the weak link is 1 rope and the strong link is 2 ropes. Don't think of them as the mathematical symbols. So what we could do is we could say 1 row 2, column 2 has a strong link to 2 row 2, column 2, which has a weak link to 2 row 2, column 8, which has a strong link to to 3 in row 2, column 8, which has a weak link to 3 in row 8, column 8, which has a strong link to 4 in row 8, column 8, which has a weak link to 4 in row 8, column 2, which has a strong link to 1 in row 8, column 2, which has a weak link to 1 in row 2, column 2. And again, that is where we started. And so this is kind of how you would write this in the strict terminology sense. So this is how you describe this loop. And so once you've made this sort of connection between these, where it sort of fulfills itself, and you've made this loop, what that has done is it converts all of the weak links in this loop to strong links. Let me say that again. It converts all the weak links in the loop to strong links. And the reason for that is a bit complex, and I think it's a bit much to go over in this video. And I think you can sort of intuit it based on this situation, where we already intuited that the result of that would happen. But the basic gist of it is, if we can kind of negate, we can kind of go backwards across this entire chain and get the same result, right? Where instead of saying we have a 1 in row 2, column 2 with a strong link to 2 in row 2, column 2, we can say we have a 1 in row 2, column 2 with a weak link to the 1 in row 8, column 2. So you can read this backwards and get another valid chain that alternates. And if you think about it, the reason we're alternating strong and weak links is we're saying, you know, if I go back to this one, we're saying if not A, then B. And then if you think about this as this way, then we can say if not A, then B, and then if B, then not A. So we're going not A, B, not C, D, not D, you know, not E, F, etc. And we're just we're alternating between not true and true, which if we alternate between strong links and weak links, we do get that result. So going back to here, we can look at this backwards, and we get, what would this describe? A 1 in row 2, column 2 having a weak link to the 1 in row 8, column 2 means if this is a 1, I have a weak link to the 1 in row 8, column 2. So if this is a 1, this is not a 1, which has a strong link to the 4 in row 8, column, oops, I missed a 2 there, to the 4 in the row 8, column 2, which means 4 is true, which has a weak link to the 4 here, which has a strong link to the 3, which has a weak link to this 3, which is a strong link to the 2, which has a weak link to this 2. And so by being able to go in both directions, we have essentially proven that one of those directions is true. And that ends up having the effect of converting all of these to strong links. So now I can say that the 2 in row 2, column 2 has a strong link to the 2 in row 2, column 8. Not just a weak link, that's a strong link. So the 2 between these two is now a strong link. And when there's, now that I've formed that strong link, I can eliminate all these 2's, which is the exact result we got when we initially analyzed this pattern. This here, this weak link between the 3 in row 2, column 8 and the 3 in row 8, column 8, that's now a strong link. These two now have a strong link between them. These are now eliminated. These can't be 3. The 4 in row 8, column 8 and the 4 in row 8, column 2, that's now a strong link. None of these can be 4 because there's a strong link between these 4's now. And then finally the 1's between row 8, column 2 and row 2, column 2, that's these two. There's now a strong link between them. None of these can be a 1. That's exactly what we had done before. So now that we know that, we can solve the rest of this puzzle. So I know you guys would yell at me if I did not do so. So let's finish this puzzle as quickly as we can. So first I'm going to do a little bit of basics that I had missed at first. First of all, where does 6 go in this row? 6 can't go here. So this 6 sees here. This 6 sees here. So this is a 6. And now where does 7 go in the same row? This 7 sees here. The 7 sees these two, so this is a 7. And so now if we look at this column, it's been affected by the 2 being eliminated here and the 4 being eliminated here. So let's look at 2's and 4's. First with 2's, where does 2 go? Well, now 2 can't go, well, it obviously doesn't go in any of the givens. 2 now can't go in this row because of our XY ring, which is very hard to say actually. And then 2 can't go here, and 2 is in this box. So this is actually a hidden single 2 now. And now where does 4 go in this box? Well, this 4 eliminates from here, and this 4 sees down here. So in the box we have a hidden single 4 right there. So now what we can do is look at 7's. So we look at where 7's can actually go. This 7 looks over, and this 7 looks up here. So 7's limited to these two. So now if we look 7 here and here, puts a 7 right there. We can keep looking at 7s. These look across in here. And then this 7 looks up. And that 7 looks up. That puts a 7 here. And that sees this corner marked 7. So we can place this 7. And now we have actually finished the 7s. So now what we can do is look at 6s. So if we highlight them, we can see this 6 looks down and this 6 looks over. That corner marked 6 is here. Now we can look over and see that this is a hidden 6 here. These 6s look up, placing a 6 right here because of the 6 as well. We should be able to finish the 6s. Not quite. So these 6s here, and that forms a final X-wing there. And so now in this row, we need a 3, 4, and 9. So we can fill 3, 4, 9 there. This one sees a 3 and a 9 in its column and its box. So this is a naked single 4. This is a 3, 9 pair. Remaining in this box, we need a 1, 3, and 5. And this sees both 1 and 3, so this is a naked 5, leaving a 1, 3 pair in the box. So now remaining for this column, we have 1, 2, 3, 4. We need 5 and 9. So now this 5 looks over here. This 5 looks up here. We can place a 5 here. Remember, this XY ring is still in effect. These can't be 2, and so that leaves just one place left for a 2 in the box. Here we have pairs left for these 2 columns. In this column, we need an 8 and a 9. And in this column, we need a 5 and an 8. And now this 9 does look over here. And this line looks down, so that means this is a hidden single 9. That makes this a 3. This 3 looks down, this 3 looks over, so we have a 3 in one of these 2. If we look at the 9s look down here, putting a 9 in one of these 2. Okay, and so now let's not forget to use our XY ring to its fullest, so these can't be 3. So if you look at this row here, this can't be 3, and these can't be 3. That leaves just one place for a 3 in the row, so that's 3 and that's 1. So now if we look at where 2s can go, this 2 is looking up here, so we have a 2 in one of these 2. A 2 can't go here because of our XY ring, so in this column, where can 2 go? It can't go here or here. 2 sees here as well, and a 2 sees here, so 2 is in one of these 2. And so we have a 3's corner marked here, 2's corner marked here, and so this cell here, if we look at what it can actually be, can't be 1, 2, 3. It could be 4, but it sees a 5, 6, 7, 8, and 9. So it is a naked single 4. That makes this a 1. Look, the 4s look up here and here, and that places a 4 here. So if we look at the 4s some more, there is a 4 in one of these 2. These 4s look over, so there's a 4 in one of these 2. This is going to be a triple, so we need 2, 3, and 5. So this can't be 5, this can't be 2, this can't be 3. And so this is going to be a pair remaining. So we need a 1. And we don't need 2, 3, 4, 5, 6, 7, 8. So we also need a 9. Here we have a 1 now. So now actually placing this 1 on our XY ring, I could have immediately gone and finished off the rest of the ring. So this is a 2, 3, and 4. So now this is not a 4. This is a pair. So we have 1, 2, 3. We need 4 and 8. And then this is going to be 1, 2, or 9. This can't be 9. So 9 is in one of these 2. Whoops. 9's in one of these 2. Here we have a triple left for the box. So we need a 1, 5, and 9. This can't be 1 or 9, so it's a naked single 5. This can't be 5. This is 1, 5, or 9. So it's 1 or 5. This cell here I put 1 or 2, but it actually sees a 1. So this is 2. This can't be 2, so we have a 1, 9 pair. That means this one is 8. Naked single 8 because it sees a 4 and a 1, 9. So that means this is 4, this is 8. This is a triple, so we need 3, 4, and 6. So this can't be 6, this can't be 3 or 4, so this is a naked 6 here. And you can see that getting that XY ring, as long as we keep applying it, we've basically got singles, maybe a couple like tuples or pointing, but nothing too advanced left to solve this puzzle. So this can't be 9 or 8. So this is going to be a 1 or a 5. So we need 1, 5, 9, or 8 left for the row. That makes a 1, 5 pair. So then this is going to be a 2, 4 pair, and this can't be 2. So this is a 4, this is a 2. That sees 3 and 4. There's just one digit left for this column. We have 1, 2, we need a 3. That makes this 2, 5, and 3. This is a 9, 8, and 5. This is 8, 9, 5, 1, 9, 5, 1, 1, 9. And then left here we need a 9. This is 6, and this is 2. And that's it. That's it for this first puzzle. So sorry for the long-winded explanation in the middle, but I hope that's useful to know when moving forward, because I think a lot of techniques that a lot of the advanced techniques that we're going to be showing in this video as well as future videos are going to depend on understanding both the terminology of strong and weak links as well as the nomenclature that I've introduced, specifically this nomenclature where we're linking candidates together with strong or weak links. And so if you remember, these were actually alternating. So we created an alternating inference chain. And by having it loop back around on itself such that there's a weak link going this way and a strong link going this way, that describes the XY ring that we actually found. And it describes the effect of it, which is that all the weak links become strong links. So now I'm going to pull up the next puzzle and we will go over that one. Okay, so this is the second puzzle. This is Inside Out by Philip Newman. And this is a puzzle he hasn't published before, but again, there's a link below if you want to try it. Now, unlike the previous puzzle, you are not going to really get very far at all. There's pretty much no basics to do. I think you might find a hidden pair somewhere, but it's not going to be all that helpful. So we're just going to start right away with the technique. So what we're going to observe is that in this column, where does 1 go? Well, the 1 here sees these 3, and this one sees this one. So 1 is limited to 2 places in this column. And we're just going to represent that. You know what? We're not even going to use colors. We're just going to represent that with corner marked 1s. And so normally I use corner marks for boxes, but in this case I'm going to use it for the column. And then in this row, where does 2 go? Notice that we have these nicely placed 2s, 3s, and 4s, so you'll probably see where this is going. The 2 can't go here, and then we have this 2 here that blocks it from here. So 2 is in one of 2 places. And then this 3 can't be here. This 3 sees here. So 3 is in these 2 places. And this 4 sees these 3. And this 4 sees here. So 4 is in 2 places. So what do we have here? Well, it's not quite the same as the previous puzzle. It's not an XY ring. You remember the XY ring, which is still very difficult to say. We had a 1, 2 here as center marks, a 2, 3 here as center marks, 3, 4, 1, 4 as center marks. And so we had a strong link inside the cell, and then between the cells we had a weak link. Well, what Philip has done here is he's reversed it. So if we were just thinking about XY rings, we wouldn't necessarily think that this was the same technique. But if we're thinking about our strong and weak links, it's the exact same pattern. It's just the type, what causes the strong link and what causes the weak link is a little bit different. So let's pull up a previous notepad here and examine this one. We had a strong link, then a weak link, then a strong link, then a weak link, and it came back around and ended up in the same location with a strong link in one direction, a weak link in the other direction. So let's pull up a new notepad. And again, I'm gonna use a big font so you guys can see it, but maybe not as big as the huge font. So what I'm going to do is I'm going to say, well, first of all, I guess I'm going to point out, we do have strong links here. There's a strong link between these two ones. Remember my X-wing example, there was a strong link. There's a strong link in this column. And the strong link is because if this one's not a 1, this one must be a 1. and vice versa. If this one's not a 1, this one must be a 1. There's a strong link between these two because nowhere else in the column can be a 1. There's a strong link between these 2s, there's a strong link between these 3s, and there's a strong link between these 4s. So what we can say is that 1 in row 1, column 1 has a strong link to the 1 in row 9, column 1. We have that strong link. Now, one thing to point out with this nomenclature is if the strong link is between the same candidate, you can omit that candidate, and that's kind of implied. I'm going to keep it, but you'll probably, like, if you see this written somewhere, for people who use this terminology, they'll probably omit that because it's implied that the strong link here preserves the candidate if it's not specified. But I'm going to specify it because we are going to be going forwards and backwards, so we kind of want to be able to read that either direction. Now, the 1 in row 9, column 4, let's think about it. What weak link does it have? It has a weak link to the 4 in the same cell. Now, this cell can be more than just 1 and 4, but what we can say is that if it's a 1, it's not also a 4. There's no Schrodinger cell, as Simon would say. So there is still a weak link, and within every cell, there's a weak link between every candidate of that cell within that cell. So there's a weak link between the 1 and the 4 in row 9, column 1. So I can just write here, there's a weak link to the 4 in that same row 9, column 1. Now we know that 4, that exact 4, it has a strong link. It has a strong link to the 4 in row 9, column 9. Because within this row, 4 is in one of two places. So I can say that has a strong link to 4 in row 9, column 9. Now that 4, guess what? It has a weak link. It has a weak link to the 3 in the same cell. So that has a weak link to the 3 in row 9, column 9. Which has a strong link to the 3 in row 1, column 9. Which has a weak link to the 2 in row 1, column 9. And guess what? That 2 has a strong link to the 2 in row 1, column 1, which has a weak link to the 1 in row 1, column 1. So just for comparison's sakes, I'm going to take this here. I'm going to copy it down here. If we look at our nomenclature, we just look at the links. It's the same pattern. We have a strong link and a weak link every other, and we're ending with the same candidate in the same cell, and in one direction we have a strong link, in the other direction we have a weak link. Which means we have the exact same thing. And this is more generically, like it's not an XY ring, because an XY ring specifically was the case of candidates within the cells being by value, which then form like a ring, right? In this case, it's also a quad. But in this particular case, this is the more generic term for this, which would also apply to this, is a continuous nice loop, CNL. And a continuous nice loop is identified by alternating strong and weak links to start and end at the same cell with a strong link in one direction and a weak link in the other direction. And the result of finding the continuous nice loop is that all the weak links become strong links. So what does that mean in this case? And I'm gonna get rid of this so there's no confusion. This weak link becomes a strong link. What's the weak link? It's between the 1 in row 9, column 1 and the 4 in row 9, column 1. That becomes a strong link. Well, how do you make a strong link between two candidates in the same cell? That means one or the other is true. So any candidates that have a weak link to both of them must then be false. Because a weak link says one of these two is true. There's either a 1 or a 4 in there. So you can't have a 5 in there, because the 1 and the 4 in row 9, column 1 have a weak link to the 5 in row 9, column 1. So that means that what we can do is we can take in row 9, column 1, which is here, we can change those corner marks to center marks, because it's a 1 or a 4. There's a strong link now between that 1 and the 4, which means none of the other candidates in that cell can be true. And that's true of all of these. So if I just keep going along, I have this weak link between the 4 and the 3 in row 9, column 9. Guess what? That's now a strong link. This is now a 3 or a 4. Here, this is a 2 or a 3. This is a 1 or a 2. So now I can get rid of these corner marks so we don't have any confusion here. And this is a much stronger statement, right? this means this can't be anything other than 3 or 4. This can't be anything other than 1 or 4. This can't be 1 or 2. This can't be anything other than 2 or 3. So we've now eliminated a bunch of candidates from these corner cells. So what we can see is that all Philip has really done is he said, let's take the XY ring, let's take the logic of it, let's turn it into strict terminology. Let's write out the equation for it, and let's make an equivalent equation of strong links and weak links, but let's turn it on its head. Instead of the strong links being by value cells, the strong links are rows or columns with only 2 places for a candidate. And instead of the weak links being between 2 cells, the same candidate between 2 cells, the weak link is different candidates within the same cell. So I think that's really cool. So you can sort of, I hope this opens up possibilities in your mind to take patterns that you've seen already in Sudoku, in classic Sudoku, and turn it on its head a little bit and get creative. How can I use the same strong links and weak links, but do it in a way that's the same pattern but a little bit different, and sort of warp the mind a little bit. So anyway, what we can do is we can finish this puzzle now. So we can start by saying, where does 9 go in this column? Well, this 9 sees these 3, so this one is the only place for a 9 in the column. And that's because these can no longer be 9. You can see they used to be able to be. And now these 2 7s, they look over into this box. This 7 looks down, and now that that's a 9, this is a hidden single 7. And we also have a mirror of this 9 here. This 9 here sees these 3, so this is a 9. And then we have this mirror here of these 2 5s, and this 5 looking up, so this is a 5. These 2 5s look up, so we have a 5 and one of these 2. And we can take a look at 9 since we just got a couple of them. So these 9s look up, this 9 looks over, so there's a 9 here, 9. And we have a mirror of that, so these 2 9s look down, this 9 looks over, so there's a 9 here. And now in this row, what do we need? We need 1, 2, 3, and 8. And this one can't be 8, so we have a 1, 2, 3 triple, making this one an 8. This can't be 2. And down here, we kind of have a mirror of that happening. So we need a 1, 3, 4, and 6, and then this one can't be 6. So this one's a 6, and this can't be 4. These 2 6s look up here. That makes this a 6. The 6s look over here. That makes this a 6. And this 6 sees down, and this 6 sees over, so that's a 6. And we should be pretty close to finishing the 6s. We have 2 here, and we have 2 here, and that forms a 5, 6 hidden pair. If you look at this column here, where do 7 and 8 go? 7 and 8 can't go here. 7 and 8 can't go here, so this is a 7, 8 hidden pair, leaving another pair behind, which is a 1 or a 2. This 1 sees here, so that's 2 and that's 1. And so now this one looks over, this one looks up, so we have a 1 and one of these 2. These ones look up, so we have a 1 and one of these 2. This one looks down, so there's a 1 and one of these 2. So now in row 7, what do we need? We need 3, 5, and 8. And these 2 8s see down, making a 3, 5 pair, so this one's an 8. And then these 2 8s also see down into here, making this an 8, it's a hidden. And we need this 3, 5 makes this a 1, 4, and 3. This is now the only place for 1. This is a 1, 3, and 2. The 2 sees down, making this a 1, 2 pair. And this there's just 1 left for this box. We need a 3. And in this box, we need a 4. This 3 sees down, making 5 and 3. This box, we need a 3. We need 2 left in here. We need a 2. And we also need a 9. Here we have 2 left. So we need a 1. And we need 4. This 1 sees 2 and 1. We need a triple left for the box, so we need 3, not 3, we need 4, 5, and 6. So that's not 4 or 6, so that's a 5. leaving a 4-6 pair, which is not resolved yet. For this column here, we have 3 remaining. So we have 1, we need 2, we have 3, 4, 5, 6, we need 7 and 8. This can't be 8. This can't be 2. This can be any of 2, 7, or 8. So this has a pair remaining. We have 1, 2, we need 3 and 4. So this sees the 4, so that's 3 and 4. That's 6 and 4. That 6 sees 5 and 6. These are not resolved yet. So what do we need here? 2, 7, or 8. So that can't be 8 or 2. So that's a 7. This is 8 and 7. This is 8. This is 2 and 7. And in this box, let's just see what we need. We need a 2, which is going to go here. We need a 3, which goes here. We need a 5, goes here, and we need a 9. In this box, sorry, this 2 sees over. Let's just do that. This needs a 2. This box needs a 1, which goes here. Needs a 4, goes here. We need a 7, goes here, and a 9. And finally, over here, we need a 4 and an 8. And there we go. So that solves Philip's puzzle, which, if you tried it, you may have struggled a bit more than just one opening move and then a bunch of hidden and naked singles, basically. So hope you enjoyed both of those. I hope you enjoyed the explanation of strong and weak links and how to do alternating inference chains and the continuous nice loop, which is one result of alternating inference chains. We will be using those much more in the future. So if you didn't understand it, please rewatch this. I'll try to do reminders in future videos, and I will do a more in-depth discussion with Philip, hopefully, in the future about links and how they're used. So look forward to that as well. And if you are not subscribed, please do subscribe and like the video and comment and all that good stuff. And also, I do stream twice a week on Thursdays and Saturdays, so you can check me out then as well. And I also have a Discord server, which is in the description, so you can keep up to date on what I'm doing both in YouTube world and just general Sudoku world. And other than that, hope you're looking forward to the next classic Sudoku video. And thanks for watching.